Well, hello, welcome again, PC Calculus students. We're ready to take a look here at our scoring video for the 2018 free response questions. So let's go ahead, and these are questions, I should say, we're looking specifically at questions 4 through 6. So here's question 4. So we're given our table of values here. And notice we have values for height, we have values for time, and so we also know that this height function is twice differentiable, so we can find second derivatives. And so let's see how to score what you've done. So first, as we look at this, on part A, we're finding an average rate of change. So we need to approximate using our ratio here. We need to see this ratio of differences. So we need to see here a ratio of differences in some point here, and we get 5,2. And then we need to correctly interpret and use units. So having the correct ratio here gets us 1 point. And then interpreting, which is the rate at which the tree's height is changing in meters per year. You have to say the correct units, meters per year, at a time of 6 years. And you have to specify at the time of 6 years. So all that has to be specified when you give your interpretation. Okay, then part B. Part B, we also see, now we're going to use the MVT. We have to find the average rate of change. Notice it's in a different interval, so we do need to see a different average there being 2. And because it's differentiable, you must say continuous and differentiable here. So you have to specify the conditions on that interval. Then by the mean value theorem, you must reference the mean value theorem. There does exist a point C in between 3 and 5. Now you could say that just in English. There exists a value C. You could say between 3 and 5. You don't have to use the notation, although it's more concise, such that we know our derivative is equal to 2. So you get 1 point for your difference quotient. We need to see the difference quotient there. If we don't see that difference quotient, no point. And then if you conclude correctly using the mean value theorem, then you get your second point. Once again, requires that you have your reference. You reference the mean value theorem. You list the conditions, the continuous and differentiable. Part C. Okay, part C asks us to approximate the total growth. And so, actually, sorry, we're approximating getting the average value, the average height over a given amount of time. So it's not the average rate of change, it's the actual average height. So this is our integral divided by our interval. So we first off need to see the integral approximated by the trapezoidal sum. That is this part that is right in here inside the parentheses. We must see that sum inside the parentheses, which means we must see addition signs, and we must see areas of trapezoids here, not just numbers, but actually things that are distinguishable as areas of trapezoids. And then if we actually multiply by 1/8 correctly and get this value here, we get our point. By the way, both points would be earned by this line right here. That line right there would earn us both points. We could just stop at that point. Okay. Then part D is worth 3. So you get 2 points if you correctly evaluate the derivative, and then you have to do this implicitly, of the g of x function with respect to t. Okay? So when you do that correctly, you will get this expression right here or right here. Or you can have the dx dt multiplied by this and then by this also. That gets you your correct expression there. So that's kind of a package 2-point deal. If you don't take that derivative with respect to t and don't get that with your dx dt. If you make a mistake and you don't have your dx dt on both terms, I believe you can get 1 point, but that would be the limit of it. And then notice here, if you don't use the chain rule, in other words, if you don't get your dx dt, the most you can get is 1 point. So my guess is even if you did the derivative here and got this just derivative with respect to x, that'd get you 1 point, but that would be it. Can't get any more. And finally, you'd filling in the values and evaluating, you get 3/4 with your answer. Okay, score that out of 9, and let's go ahead and let's look at number 5. So number 5, part A, worth 3 points. So 1 point is for your constant and limits. So here's your constant. You need to know that you're multiplying by 1/2. That can be inside or outside, and then you have to have the correct limits. That gets you 1 point. 2 is the integrand. So that's this thing inside the parentheses here. And you need to have the, so you can write this as 16, that's fine, minus this thing squared. I'm trying to remember exactly the way they would usually do this. If you forgot the 4 squared and you just had this, that would get you 1 point. Okay, just the 4 squared doesn't get you any points. But if you did have this and knew to square it, you would get 1 point. If you didn't square it, but you just took the difference of those things and you forgot to square it, or you squared the outside, the whole thing, I believe you would get 1 point for that. But that would be it. I think that would be the extent of it. Okay, then part B. Part B, you get 3 points. You get 1 point if you express that your dy d theta is equal to your dr d theta times sine of theta plus r cosine theta. That's this right here. So you get 1 point if you get that, or if you get this. So either one of them would get you 1 point. If you get both of them, it's still just 1 point. But if you do either one correctly, you get 1 point. Then if you get your dy dx correctly, which is where you actually plug those in and take the ratio of those two expressions there, then if you get your dy dx correct, then you get another point. And then finally, if you evaluate correctly, plug in the correct values that you got from up here evaluating and get your 2/3, then you get it. You get your point there. Alternative way to do this is written out here, but you still have to get the 2/3. Okay, this is converting it to y and x first, and then just taking the derivative with respect to theta. That also works. If you did that, change it to x, change it to y, and then just took a derivative with respect to theta. But once again, you got to have the correct derivative with y, correct derivative to x. You must have changed it correctly and gone on and done it that way. Either way works. Then for part C is also worth 3 points. So there's 1 point for getting the correct dr dt, which does require a chain rule in action here. So getting that, we do end up with that being expressed here as this -2 sine theta d theta. And then if you solve it correctly for d theta, so getting to here gets you 1 point. Solving correctly for d theta, there gets you a 2nd point. And then actually evaluating correctly and including units, you must include units to get the 3rd point, and getting that negative radical 3, that gets you your 3rd point. Okay, go ahead, score that one out of 9. And let's move on to question number 6, our series question. So first, you get 1 point for the first 4 terms. Here, 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 here. It's just simple. 1 point. Got to have the correct signs with it. It's either all or nothing on that 1 point. And 1 point for the general term. There's our general term right there. You get 1 point for that. It can be listed as a part of in summation notation, but doesn't need to be, because it just said find the general term, an expression for the general term. Then for part B, it is worth 5 points. So a lot of points here on part B. It's the bulk of the question. So you get 1 point if you set up a ratio. So if we see this ratio here, you get a point. You get another point if you compute the limit. So if you knew to take the limit as n goes to infinity of this ratio, now you get an additional point. If you find the radius of convergence being 3, I should say you actually have to calculate a limit there, not just say that's what you're going to do, but actually do come up with calculate a limit. And then if you actually do get the correct radius of 3, you get another point. Okay, now you have to consider the endpoints. So now I will say this, they are showing you another way to do it. The other way to do it is to change this, is to recognize this series is a Maclaurin series for the natural log of 1 plus x. And so if you did that, then you could simply find the radius for that series and then go from get your radius there. So that's the other way to do it. I doubt anyone did it that way, but just be aware. But then for the other 2 points, you must consider your endpoints. So you must consider when x is -3 and also when x is 3. So you just get 1 point just for considering both. Okay? So just considering one doesn't do it, but if you consider both, you get 1 point. And then if you actually correctly analyze and get that it's that it diverges at -3, converges at 3, so we have this open interval on this end, closed on that end, you get your 5th point for that. Then for C, 2 points here for this error bound. So first you get 1 point if you understand you must use the 5th degree term. Okay, just understanding you have to use the 5th degree term gets you a point. And then if you actually correctly evaluate with the 5th degree term and get your error bound, you do get your 2nd point. Okay, score out of 9, score the whole thing out of 27, and then go ahead and take a picture and turn that in. Hope things are going well. I'll get you some updated information here on the AP test coming up, and hope you guys are preparing well. If you have questions, I should say, if you're curious about how something is graded, when you go ahead and take a picture of your work, when you send it in, just include a comment to me, something to the effect of like, on number 6C, I wasn't sure whether I should have, how many points I should have got, and I'll take a look at that and I'll let you know exactly how many points your answer would have earned. So go ahead and do that if you have any questions on those. Other than that, we will have a Zoom session if you have questions on Friday. All right.